Howdy, IB. It's Miss Kosh. We are going to talk about factorials today. A little side note, I'm going to tell you a funny story of me and the internet trolls. So it's coming. I deleted names because I don't really want to incriminate people, but the whole thing is pretty hilarious. So first of all, let's define what it means to have a factorial. A factorial we write with an exclamation point, and so something like, oh, hang on, I forgot. If I have something like, oh, that is not going to work. Sorry, I should have fixed this. If I have something like 4 factorial, what this means is I'm going to start with that number, and I'm going to multiply by every integer as I descend down. I'm going to multiply by 1, and then I'm going to stop. I'm done. So notice real fast here. So if I have 4 factorial, 3 factorial, would you agree? Well, 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Yes, this seems tedious. 1 factorial is just 1. The question becomes, what is 0 factorial? Okay, so that's the question. One of the proofs that I've seen, well, 0 factorial is actually equal to 1. And we need it to be that way, or the whole world falls apart. Well, not quite, but it becomes a problem. One way to think of this is that 4 factorial is equal to 3 I lied. I did 4 times 3 factorial. And then 3 factorial would be equal to 3 times 2 factorial, because notice here, I think that's going to be too wide. Okay, what I have, this 3 factorial here is equal to this. So this is 4 times 3 times 2 times 1 can be rewritten that way. 2 factorial is equal to 2 times 1 factorial. 1 factorial is equal to 1 less than that is 0. Wait, I did it in the wrong order. Sorry. 1 times 0 factorial. So notice here is what I'm showing you here is that this number 4 matches this number 4, and then it's the 1 less factorial. So 1 factorial is equal to 1 times 0 factorial. Well, notice from here that if I have 1 factorial and I say that that's equal to 1 times 0 factorial, well, 1 factorial we know to be 1 is equal to 1 times 0 factorial divided by 1. 1 is equal to 0 factorial. So that's one little proof that we can use there. Another way to say that is n factorial is equal to n times n minus 1 factorial. So notice if n is 4, 4 factorial is equal to 4 times 3 factorial, and so forth. Okay, so let me work a few examples here for you. Let's get rid of that. On this one, so the first one they say write as a product of factorizing, and they have this 8 factorial plus 6 factorial. Oh, okay, my bad. 8 factorial plus 6 factorial. Well, what I notice is that this is 8 times 7 times 6 factorial plus 6 factorial. And now something shows up in both terms, and that something is 6 factorial. So I could factor out a 6 factorial. Well, and then I have an 8 times 7 from this first term, plus, well, and I need something to hold its place. So if I were to multiply back, and this right here, I'd need to have a 1 here so that I could multiply back and actually get this 6 factorial. Okay, so what we have is this, we factor out a 6 factorial. We have 8 times 7 plus 1. 8 times 7 is 56. 56 plus 1. So what they wanted here for that problem is 57 times 6 factorial or something like that. 6 factorial times 57 is what they said. Fantastic. That's great. The next one, they said, don't look at the answer. They said 10 factorial minus 9 factorial plus 8 factorial. 10 factorial minus 9 plus 8, not 9, but 9 factorial. Okay, so this is 10 times 9 times 8 factorial. Why did I stop at 8 factorial? Because that's the smallest factorial that I see. Minus 9 times 8 factorial plus 8 factorial. Now I see that I've got an 8 factorial in every term. I can factor it out. And, okay, that's 91 minus 9 is, well, let's see, that's 81 plus 82, so 8 factorial times 82, or something like that. How did they write it? Something like that. Okay, so then the next one, they say simplify 7 factorial minus 6 factorial over 6. Is it just over 6, or did they intend that to be 6 factorial? No, they intended, oh, okay, that's what happens. you know what, I'm going to do both, actually. So I'm going to do this is the problem that they wrote. This is the problem that I expected to see. We'll do them both just for the fun of it. Okay, so on this first one, this is 7 times 6 factorial minus 6 factorial over 6. I can factor out the 6 factorial. Okay, keep in mind that when you write these, you need every step to be true to the one above. Granted, we're not working here in the bottom at this point, but you can't lose it. So that's one mistake I often see, that people will just like work where they're working and not keep the whole problem equal to what came before. So don't do that. And then notice this is 6 factorial times 6 over 6. The 6 is canceled, and my answer was just 6 factorial. On this one, we can say, well, this is 7 times 6 factorial minus 6 factorial over 6 factorial. Lots of 6 factorials. Factor out a 6 factorial. And this is going to be kind of the opposite problem that we just saw. The 6 factorials cancel. And 7 minus 1 is 6. And so life is good. Okay, there are those problems. Let me make up one, simplify it by factoring. Let me make up one with letters. So if we have something like, I want you to practice the ones here, but let's say I have n plus 2 factorial over n factorial. Is that on there? No. Okay. What we know that n plus 2 factorial is going to be n plus 2 times the integer just smaller than that, which is n plus 1. Which is times the integer just smaller than that, which is n, well, and then I could keep going. I don't know how far we're going, but what I do know is that this becomes n factorial at this point. Now, why did I stop there? Because I now see that my n factorial is going to cancel with my n factorial, and so this just equals, well, n squared plus 3n plus 2. If I had something, let's do one more. Our favorite letter is k. Let's do k minus 1 factorial over k plus 1 factorial. Okay, what we know on this one is the bigger integer is going to be down at the bottom, and so this becomes a k plus 1 times a k minus 1, and I can keep going, or I can just call it factorial at that point, and this is a k minus 1 factorial. And now what we see is that cancels with that. Don't forget to leave something in the numerator, so this is 1 over k squared plus k. Okay, and now let me show you this little thing. Somebody was, I don't know, I follow interesting people on Twitter, and so somebody said something about 2 plus 2 equals 4, and there's been this whole hoopla about 2 plus 2 doesn't equal 4, which is silly. Well, so this guy, and I'm hiding his name, he says, that's why 2 plus 2 equals 4 exclamation point. So I should have left it alone. Anyway, I did not. And so I said 2 plus 2 doesn't equal 4. 4 exclamation, 2 plus 2 equals 4. Sorry, I teach factorials every year. I was trying to be playful. I failed, apparently. So then this guy says, I feel sorry for your students. Well, somebody else jumps in and says, check your punctuation. I tried to keep the colors so that you can see where it's different people. So really, his only problem, I agree with everything he said, except he can't put this 4 exclamation. So, but then I thought, so I said, some of them feel sorry for themselves too, when he said, I'm sorry for your students. I said, we use factorials and proofs and probability. They tend to love them or hate them. So that's you guys that I'm talking about. And then he jumps in again, equation. Do you know what that is? This little thingy, equal, is called an equal sign. That's why we do it, because it's balancing the equation, which actually isn't balancing the equation chemistry, but whatever. So I keep talking, and I probably should have left it alone. And he says, you don't get it. 2 plus 2 equals 4 by definition. The only way you can make 2 plus 2 not 4 is by cheating. And so at this point, I look back at your original tweet. I'm on your side. I promise. My only point is that 4 factorial means something different in math besides 4. So then he accused me of cheating, which is ridiculous. Then he says, the part that just totally cracks me up is, remember, the exclamation point was never part of the equation until you decided that it was. Well, I don't know that I agree with him. And I will say this to you guys. If you ever write 2 plus 2 equals 4 exclamation point, I'm going to count you wrong. Because here's what he's saying. He uses 1, 2, 3, 4, 5 math symbols, and then expects me not to expect that last one to be a math symbol, which, anyway, maybe you agree with him, but I thought it was kind of absurd. And math is a language of precision, and that exclamation point means something. So then these other people got involved. You have no idea what factorial, and I tried to be kind. I tried not to be ugly, but anyway. And then I realized I'm done. I'm at this point after this one, after this this message. I thought I'm out. I'm completely out. But people kept replying. You have no idea what factorial means, and that your use of the exclamation symbol has that real mathematical meaning. And then he's like, is exclamation part of the equation? No, therefore it's irrelevant. Well, no, dude, you can't write 5 math symbols and then expect the 6th one to all of a sudden not be math. So somebody else, you used a symbol incorrectly. And then it got even better. This has got to be one of the stupider things to argue about. So the poor dude, anyway, he never learned. So he used it as an exclamation point. Yes, an actual exclamation point, like shouting, exclamation point. This is so stupid. Well, he's right. But anyway, here's my point to you guys. Precision matters, and that exclamation point means something in math, and now I hope you know how to work with it a little bit better. All right, sorry, thanks for indulging me. Go practice.